This is the iota, which is under root of -1. If we raise it to the power of iota, the result is surprisingly a real number. In this video, we'll go into depth of what raising any number to power of iota means. Let's suppose we have a positive real number a. Next, we raise it to the power of iota. Let's say it is equal to r. If we take natural log both sides and simplify it, we get r equals e to the power iota ln a. Now, if we compare it with the general representation of complex number in the exponential form, we conclude that it is a complex number with modulus 1 and argument equal to ln a. Looking at it geometrically, on the complex plane, it lies on a circle with radius 1 at an angle ln a radians from the x-axis. So we conclude that raising any positive real number a to the power of iota is equivalent to rotation on the unit circle in the complex argand plane by an amount equal to its natural log. So far, we look at positive real number. Let us now quickly understand what happens in the case of negative real numbers. We have minus a. We know that minus 1 can be written as e to the power iota pi. So we can write minus a as a times e to the power iota pi. Raising a to the power of iota, we get a to the power of iota and e to the power iota pi whole raised to the power iota. On simplification, we have e to the power minus pi times e to the power iota ln a. Here the modulus is approximately equal to 0.0432. So in this case, the result will lie on the circle of this radius instead of 1. Now we'll go on to show the function f of x, which is x raised to the power iota graphically. Below is the x-axis. You can see that on moving it, it traces out circle with radius 1. Now here we move in the opposite direction, covering the negative real numbers. Here same as before, f of x traces a circle. But here the radius is close to 0.043 instead of 1. Before we move on, I would like to remind you to consider subscribing. Now we'll move on to a general case, raising a complex number to the power of iota. Any complex number can be represented as r times e to the power iota theta. On raising it to the power of theta and simplification, we get e to the power minus theta times e to the power iota ln r. The first is responsible for shrinking the magnitude, and second one is responsible for rotation. A thing to note here is that net rotation in the number is ln r minus theta counterclockwise. Ln r is a final angle made by the result with the x-axis. We can easily see that if we increase the argument of the given complex number, the modulus of the resultant number decreases. Hence, graphing it will give a spiral. Now, let's solve for iota raised to the power iota. Using the following general result obtained previously, here z equal to iota. The modulus of iota is 1 and the argument is equal to pi by 2. Plugging the values, we get the result approximately equal to 0.20788, which is a real number. Let's look at it graphically on the complex arcane plane. We have iota on the imaginary axis. On being raised to the power of iota, it will go through a rotation of ln r minus theta. As r equals 1, it will rotate in the clockwise direction by pi by 2, bringing it back to the real axis. Further, it gets shrunk by the term e to the power negative pi by 2, giving the following result. Thus, we conclude that any number raised to the power of iota represent rotation of circle of radius e to the power negative of argument of that number.